Well, here we are with one of my newest games in my collection, although the game was invented in 1971, so it's not that new. It's older than me. This game is called Impact, and as the name implies, there was one of our impacts right there. So here's how this game works. One of the partners is going to start with the marble, and they're going to start on either end of the track. The other one starts with a pendulum, trying to knock the marble off the track to earn points. Okay? And of course, if they miss, the other partner can grab it and gets to throw it. So Maya here is ahead of Simone, my other wonderful partner here, teaching us the game. So this is an excellent. Ooh, Maya's on fire. That's 3 in a row. Hey, hey. So this game is a beautiful demonstration of Newton's first law of motion. Remember, Newton's first law of motion says that an object in motion will remain in motion until acted on by an outside unbalanced force. And you can see our marble right now is staying in motion, hey, until it's impacted by the outside unbalanced force of the pendulum. Right on cue. Nicely done, Simone. It's like you practiced it perfectly like that. Hey, that outside imbalanced force of the pendulum knocks it off and stops its motion. But interestingly enough, remember, all objects in the universe obey Newton's first law. So we can see the pendulum acting on Newton's first law as well. It stays in motion entirely until it impacts the ball just like that once again. Well done again, Maya. Nice timing. Hey, or you'll notice that the partners on opposite sides, hey, will also create an unbalanced force and try to stop the pendulum. They're starting to get better and better at this game. Although you'll notice that they're only getting it in the 100 and occasionally the 200-point bin. None of them are trying to throw the hard shots over here for the 500 points. So maybe they're not as good as they're trying to pretend. Keep in mind that if you do throw it too hard, it's going to hit the other end, and then we're going to have an unbalanced force. Oh, see, 200, still just not quite pro material yet. Okay, so getting there. Hey, now, the interesting thing about this is it also demonstrates really, really nicely Newton's second law of motion. It takes a force. It takes a force to. It takes a force to accelerate a mass. Okay? When they release the marble on the top of either track, gravity is going to start the marble moving downwards. The same thing's true about the pendulum. Okay? But we also have the sideways acceleration, and it takes. Not sure that one counts. Not sure that one counts. Somebody bumped the table or something. Hey, it takes a force to accelerate a mass. So the only way that the marble is going to fall off the track and accelerate in a sideways. There, we finally got a 500. I knew if I challenged them, they'd just see me as being a jerk and try to prove me wrong. Hey, because that's the kind of troublemaker these two are. Hey, it takes a force to accelerate a mass. And we have the force of the pendulum hitting the marble sideways, causing it to accelerate sideways, Newton's second law. Now, the third law of Newton's law is Newton's third law of motion states that for every force, there is an equal but opposite force. And you have to watch really closely for this one to happen. And it's right at the point of impact. Right there at the point of impact, you notice that the ball reacts, hey, to the pendulum. That's the force, hey, accelerating one mass. But the equal and opposite force is the ball pushes the pendulum. Watch it again this time as the pendulum then rattles and reacts. So that would be the end of our game because we've got 10 chits off. But notice how the pendulum reacted to that last ball. It stopped moving too. We've got the ball and the pendulum each causing equal and opposite forces on each other. Hope you like this game. This is Impact. Thank you, Maya and Simone.